Thanks for tuning in. In this video, we will discuss our question 7. It's a question on energy and chemical change, as well as the empirical formula. Right, so in the description below, we'll tell my links for my questions for this question paper. In this video, we'll focus only on question 7. Right, now, Batilana, the equation for the combustion of butane gas is given below. So butane is normally a gas oyithola kuma gas tanks, kuma gas cylinder. Lento sithi gas usual nokuthola ibutane ngaphakathi. So ibutane is well known for its combustion ability, or it's a gas ekwazi ukubhena kanje, uyabona? So here's ibutane siyayicombusta ke, and i-reactor nani the oxygen to produce the carbon dioxide as well as amanzi as a gas, carbon dioxide as well as gas, and then delta H is less than 0. So it means what? The delta H means what? It's a exothermic reaction. Now 7.1 define the term activation energy. So in activation energy, activation energy, it's the energy required to kickstart a chemical reaction yakho, right? Remember, butane, for instance, a gas cylinder, it's not like we vula and then we expect ukuthola. It's not like a gas cylinder we vula then uphuma umlilo, right? You need to kickstart the reaction by doing what? By mhlawumbe ungasebenzisa i-gun light, or ungasebenzisa u-matches ukulayita leyo gas yakho. So that energy leyo eyiphuma from i-gun lighter yakho or matches wakho, it's called the activation energy, because yiyo kickstarter leyo reaction, which is the combustion reaction. So singayidefine sithini? Singathi it's the minimum amount of energy needed or required for a reaction to take place. 7.2 is the combustion reaction of butane, exothermic or endothermic. It's obvious, exothermic, it gives out the energy, right? A combustion of butane, it kickstarts a reaction where exothermic reaction, because we need the energy to do what? To cook, ukubilisa amanzi, stuff like that. Ukhanyisa i-gas stove, right? So leyo reaction iba exothermic, then the heat ephuma lapho kuleyo exothermic reaction becomes useful for us. Yes, so it's exothermic reaction. Give a reason for your answer. Energy is released during a reaction. 7.3 again. But it draw a sketch graph of potential energy versus cost of reaction for the reaction above. So this is, since the reaction above the exothermic reaction, I'm expecting a curve ifana na this one. The energy of the reactants is over less than the energy of our products. Less than the energy of our products, is it? The energy of our reactants is over higher than the energy of our products in a what? Yeah, exothermic reaction. Exactly. The reaction is releasing. I'm a bit confused, but anyway, reactants azobana more energy than the product. So this is the shape of a curve, or the potential energy versus cost of reaction graph. Now clearly indicate the following on the graph. So for 3 marks, you need to show activation energy, heat of reaction or enthalpy H, ama reactants nama products as well. So I think suse logo. Now siyaku 7.3. This is 7.3. Na igraph yami ke. Igraph yami include the time on the x-axis, and on the y-axis ngiba the potential energy. So therefore the reactants azoba nani? na higher energy than the product, since the reaction in the exothermic reaction. Alright ke manje sesine mark eli1, sinama products, sinama reactants, nama products. Now let's show we activation energy. Activation energy is the energy required to do what? To activate or kickstart a chemical reaction yethu. So ngidinga a certain amount of energy called the activation energy to start the reaction. The reaction yami ayiqali ngama-reactants. I need a bit of kick to kickstart the reaction. So from this point, once ama-reactants aba potential energy engaka, they start reacting. After reacting, I release energy to form new products. So this is activation energy, 2 marks. Let's go for the enthalpy. Enthalpy H, it's the distance or the energy difference between the products and the reactants. So load delta H, so it's delta H. So this is our sketch. So it's 1 mark, 2 mark, 3 mark. 7.4, determine the empirical formula of butane gas if it consists of 82.76% carbon and 17.24% of hydrogen. Right, 7.4 sine carbon with a percentage of 7.6%, and then sibe hydrogen with a percentage share of 17.24%. 90 yenzekayo ke na. So since ngifuna empirical formula and the percentages are given for the different elements angisho. So lana ke sithatha ama percentages, or there's a percentage share. We must calculate the empirical formula sisebenzisa a 100 gram sample. Sisebenzisa a 100 gram sample. So 100 gram sample ngine carbon share of 82.76 grams. Yeah, and then go hydrogen nginani ngine 17.24 grams. In a 17.24 grams. So I basically change the percentages to ama grams. Why I change it to ama grams? Because of komele uma calculate empirical formula, I need to change ama values or ama percentage shares to ama moles. I can only calculate empirical formula using the number of moles. So hence I'm changing ama percentages to ama grams using a 100 gram sample. So in 100 grams, 82.76 grams of carbon based on this percentage, and then for the hydrogen, this much amount of hydrogen in the 100 gram sample. So asiyeke manje. Now for carbon, so calculate the number of moles is equal to mass, which is 82.76 divided by molar mass of carbon. It's 12 equal to 82.76 divided by 12 equal to syntax error. Okay. Divided by 12, let's go, is 6.896 moles. And then for hydrogen, in a N equal to 17.24 divided by the molar mass of 1, so in a 17.24 moles. So now then ngiyabuya ke manje ngithatha the number of moles for a carbon compare ne-hydrogen. So for carbon ngina 6.896 to 17.24, and then ngiyenzani, divide by the smaller value or the smaller number of moles. 6.896 divide ngithola ubani 1, so it's 1 2 17.24 divide by 6.896 equal to 5/2. No, 5/2. And then now there's a problem. 5/2. Now there's a problem. The hydrogen cannot be equal to 5/2, or the ratios cannot be, one of the ratios cannot be expressed as a fraction, but it must be a whole number. So multiply with 2 lana, we are multiplying with 2. 1 times 2, 2, and then it's 5 la. Therefore the carbon is 2, the hydrogen is 5. So this is our empirical formula. Therefore our empirical formula is C2H5. So this is the empirical formula for butane gas. This concludes our video. So thanks for tuning in, thanks for watching, and now we enjoy this video. Leave a like, ask a question in the comment section. Nangabuna a question, asikhulume. In the description below there are other link for amanyama videos for this question paper. Nangaba ngwapostanga after watching the video, just know that things will post in the future. As well as in the description, please link engishile lapha izokunceda kakhulu. Check out the website lit, kunama textbooks I believe angakunceda nangabe udinga some resources to study, udinga textbook, udinga a study guide. Go to that website uzothola all the material you need, even a question paper corner as well. So thanks for tuning in guys, asibonane kule video ilandelayo. Peace.